Good morning, girls. Today we're going to learn how to construct a factor tree. And in order to make a factor tree, you guys need to know what prime numbers are, what factoring is, and what prime factorizations are. Fortunately, yesterday we learned that a prime number is any whole number that can be divided evenly only by 1 and itself. Who can give me an example of a prime number that we learned yesterday? Sarah. 5. Good job. 5 is a prime number because it can only be divided by 1 and itself. Some other examples of prime numbers are 2, 3, 7, and 11 because those can only be divided by 1 in itself. Now that your brains are warmed up, we're going to learn a little bit more about factors, prime numbers, and how to make a factor tree. We're going to start off by learning what a factor is. That is any whole number that is multiplied together to get a product. So for example, the number 6, its 6 only has 2 factors, and that is 3 and 2. We know 3 and 2 are factors of 6 because 3 times 2 equals 6. Prime factorization is a list of prime numbers that you would multiply together to create a certain number. So the prime factorization for 6, we know, is 3 times 2 because 3 is a prime number and 2 is a prime number. So whenever you get a prime number, you're going to circle that number to show you can't break it down anymore. This is just one of many examples we are going to learn today. Now to get started, I'm going to show you how to construct a factor tree. The first number I'm going to factor is 12. And the first step I'm going to take is thinking about what factors go into 12. I know 2 and 6 are factors of 12 because 2 times 6 equals 12. I also know that 3 and 4 are factors of 12 because 3 times 4 equals 12. So I'm going to pick either one of those combinations, and I'm going to start with 6 and 2. You can pick either one, though, if you wanted to. So I'm going to put 6 and 2 and branch it down from 12. The next step I'm going to take is, can I break down 6 even more, or is it a prime number? Well, I know that 6 can be broken down into 3 and 2 because 3 times 2 equals 6. So I'm going to make another branch. I'm going to write 3 here and 2 over here because I know 3 times 2 equals 6. The next step is, can 2 be broken down even more, or is it a prime number? Well, I know 2 can only be multiplied by 1 in itself, so that means 2 is prime. Therefore, I'm going to circle 2 just to show that I can't break it down anymore. The next step is going back to 3 times 2. Well, I know 2 is a prime number from the last example, so I'm going to circle 2 as well to show it can't be broken down anymore. And I know 3 is a prime number because it's only multiplied by 1 in itself.